Welcome to the grade 8 lesson of the day. We've got 6.6, creating a table of values. So we're going to look at a few different ways that you can represent values and unknown variables. This is going to go back to some of our algebra. We're going to make a table out of some of the algebra we've done before, and we'll look a little bit about how to make a graph of such data. So let's take a look at some of the first examples here. Hold on. Before we jump right into these examples, I'm going to give us a little walk down memory lane. We're going to shift over to the screen over here. Here we go. So, grade 7. The grade 8s, when they were grade 7, took the grade 7 provincial assessment. And I would take 4 toothpicks, and I would do this. I would say, this is step 1, step 2, and step 3. And step 2 is the same, but I would extend the pattern. Step 3, these are all toothpicks, and I would extend the pattern. And I would say this one has 1 box, there's 4 toothpicks. This has 2 boxes, there's 7 toothpicks. This one has 3 boxes, there is 10 toothpicks. So then I would say, can you create a table like this? And so you would have how many boxes and how many toothpicks, like this. And so the kid would start writing it down. He'd say, well, 1, 2, 3 boxes, 4 boxes, 5, 6, 7. 1 box is 4, and then 7, then 10. And they would soon see a pattern that each box, it was growing by 3. So we'd have 1 to 4, 2, 7, 3, 10, etc. So that means if I have 5 boxes, there would be 16 toothpicks making up those boxes. And then I would say, well, what if I continued doing this and went on and on and on, and there was 51 boxes, how much would be here? This is where usually kids, they could continue the table and just say, do it all the way to 51. But every now and then, pardon me, I see you can't see the top of it there. There we go. Some kids would say, well, I know it's growing by 3. And so they would go 51 times 3. And you say, okay, well, it's going to be that many picks. But oftentimes they would forget that extra 1 from the start, that first pick. Well, once kids could do this, I would say, okay, well, can you graph that data? And for graphing the data, we would have it like this, where we would have a number of boxes versus number of picks. And so the kid would say, when there's 1 box, there's 4 toothpicks. So 1, 4. When there's 2 boxes, there's 7 toothpicks. When there's 3 boxes, there's 10 toothpicks. And then the kid can see that it's going up like this. And here's their 3 data points. And they can start to extrapolate the data. Now there's this word, extrapolate. To extrapolate means with limited information, I can project the information past what is there. So for example, I know this is going up by 3, so I can extrapolate or project forward that this will be 19, and so on. So now we get back to 51. Like I said, there's 51 boxes. Most kids would say, well, that's 51 times 3, and they'd say 153 boxes. Well, once kids could do all this, I would say, well, let's take it one step further. Can you come up with the algebraic equation? This would usually stymie them. Well, let's say B equals boxes, and P equals the number of toothpicks. So what I'm asking for them is, how many toothpicks, if I have 51 boxes plus the 1. I don't really like the B like that. It looks like a 6, so I'll try to make it a little more obvious like a B. So there's 51 boxes plus that 1 that was at the beginning. Well, since there's 3 in every box, kiddo can go like this, 51 times 3 plus the 1. That's when they see it's actually 154. So what we've done here When I started this little brain teaser in the provincial assessment last year in grade 7, I said step 1, 2, 3. I said, how many picks will it take to make 51 boxes? Kids would make a table. When there's one box, is this many toothpicks? Then they could make a graph. Then there's the algebra. What is the formula that we have? Now we're going to start using formulas like this. We're going to look at some of the examples that are being put forth in the textbook. So let's take a look at the textbook. Pardon my little bobblehead camera here. So it says, at the county fair, Misha sells hot dogs for $3 each and drinks for $2 each. A meal consists of hot dogs and one drink. The number of hot dogs in a meal, H, is related to the total cost of the meal in dollars. So the relationship H is related to 3H plus 2. Copy and complete the table for the values in the relation. So what this means is, we're trying to figure out how much the cost of the hot dog is. So I'm going to go over to the board here. And if you still need the textbook, I trust it's open where you are. We're going to say C equals the cost, and H equals how many hot dogs. So we know that the cost equals $3 for every hot dog, plus $2 because you get one drink. We have a relationship here to find a cost. So now we have an input and an output. So I'm standing in line, I'm at the fair. I want 2 hot dogs. I got to figure out what it's going to cost me. Well, if I input 2 hot dogs, well, that means I'm going to replace H with a 2. So let's do that. I want 2 hot dogs. So it's $3 times 2, because there's 2 hot dogs. Each hot dog costs $3. Plus the $2 for the drink. 2 hot dogs at $3 each, $2 for the drink. My meal should cost $8. So if I have 2 hot dogs, the output is it'll cost me $8. If I have 1 hot dog, well, let's change it to 1 hot dog. 3 times 1 is 3. 5. Well, what if I have 3 hot dogs? Well, let's put that in our equation. What if I have 3 hot dogs? Well, then it's 9 plus 2, that's 11. Now we are going to extrapolate. We're going to learn from our pattern what it is in the future. So then it says, use this table of values and figure out how much for 9 hot dogs. Well, by now, a student has probably seen that it's going up by 3 each time. So a student can probably figure out it's going to go $14, $17, $20, $23, 1, 2, 3, 4, 5, 6, 7. I don't know if that's on camera. Let's see. It is. So we can see that if we keep going up to 9 hot dogs, then it's going to be $29. So input, I'm getting 9 hot dogs. Output, it will be $29. Let's look at the next example. So it says we can represent a relation in different ways. For example, consider this relation. X is related to 20 minus 3x. And then it shows us a couple of examples right here. So I'm going to zoom in a little bit. We'll take a look at those. And you can see it in your textbook if you don't want to do the wobbly thing. So if x was 1, well, it says that 20 minus 3x. So if that was a 1, let's see what the difference would be. So 20 minus 3 and x is a 1. That means 3 times 1 is the 3. 20 minus 3, 17. Well, what if x was a 2? Is that still in the shot? Let's take a look. Oh, it was there, okay. What if x was a 2? Well, let's replace the x with a 2. 20 minus 3, instead of 3x, we replace it with a 2. So that's 20 minus 6, because 3 times 2 is a 6. So that means it's equal to 14. So the input is 1, output 17. Input 2, output 14. And then it makes this chart right here. So if the input is 1, output 17, 2, 14, 3, 11. And now we see a pattern. So we're going to extrapolate the data. We can see it's just going down by 3 each time. Now we see a graph that's related to it. And if you compare it to the chart, you'll see, because it said that when we had 1, we were at 17. When we had 2, we were at 14. When we were at 3, we were at 11. And so we can see our pattern within the chart itself. Now let's get to the example of the pizza. Saskatoon Pizza charges $11 for a medium cheese pizza plus $2 for each topping. An equation is C equals 11 plus 2n. I'm going to write that on the board. We're going to write this down really quick. We're at the swift portion of our lesson. There we go. So the cost of a pizza, I'm going to change this to T for topping, is $11 plus $2 for every topping. So here's our input. What if I want one topping? If I want one topping, well, it's going to be 11 plus 2 times 1. What if I want 2 toppings? Well, it's going to be 11 plus 2 times 2 toppings. What if I want 3 toppings? Then it's $11 plus 2 times 3 toppings. And we can already see our data is going up and up and up. Then the question on the assignment over here, it says, what if there was 5 toppings? Well, if there's 5 toppings, I can just continue in my chart here. Say, well, 4, 5. It'll be $21. Then it says, use the equation to find out how many toppings for a pizza that costs $27. So it says, let's get rid of this, we'll use the equation. So if the cost, C, is $27, how many toppings will there be? Well, now I simply need to balance the equation. So let's focus in on balancing that equation. So if the cost is 27, and the pizza costs 11, how many toppings? I want to find out T. Well, let's get T on its own. That cancels. Now I have 2 times T. I need to get it on its own. That must mean that I can get a pizza with 8 toppings to cost 27. If I'm not sure if that's right, then I'm going to double check my answer. So let's double check my answer. How do I do that? Well, I plug it in. I know the cost is 27. And we thought that the toppings would be 8 toppings. So I took my answer and I plugged it in for T. So instead of writing T, I write that. Let's see if it works out. Sure enough, 27 equals 27. So I must have been correct. I hope this video helps. Please come to me for help. I never mind having math questions, and I look forward to giving you some assistance.